Hey guys, so here in our first example, we're asked to find the absolute extrema for the given functions on the intervals. So for this function g of x equals sine x minus cosine x, we see that g of x is continuous on that interval from 0 to pi, that closed interval, so therefore we can apply the extreme value theorem. So first I found my derivative. Now to find my critical values, I'll set it equal to 0. 0 equals cosine x plus sine x. So that means we're looking for when negative cosine x equals sine x. So thinking about that interval, that closed interval from 0 to pi, where does sine and cosine have opposite signs? That only happens here. A critical value of x equals 3 pi over 4. So now that I found my critical value, I can do my sketching to see if we have any local mins or maxes in that closed interval. So I'm going to draw my sign chart. Notice it's a closed interval from 0 to pi, only focusing on one critical value here. We're comparing our derivative with our original function. So let's see, what's a number I can choose, an angle I can choose between 0 and 3 pi over 4. Pi over 2 is a nice one because I know that cosine of pi over 2 is 0, sine of pi over 2 is 1, so that's positive. It's increasing until it hits 0 here. So then what's a number I can choose, or an angle I can choose between 3 pi over 4 and pi? I'm going to let x equal 5 pi over 6. I'll do that work here just so that we don't forget we're plugging it into our derivative. What's cosine of 5 pi over 6? Well, 5 pi over 6 is in this quadrant where only sine is positive, so it's going to be negative cosine of pi over 6, square root 3 over 2, plus sine of pi over 6 is going to be positive in this quadrant, 1/2. We already found out in that last video that square root of 3, or in our last set of notes, that square root of 3 is between 1 and 2. So it's greater than 1. So this number is bigger than 1. So if I add it, it's going to be a negative value. So our function or our derivative is negative here, which means it's decreasing. So by the first derivative test, I can tell there is a local max at x equals 3 pi over 4. Now, we know it's a local max, but is it the extreme or the absolute extrema in this closed interval? So I need to check my endpoints and my local max to see which one has the highest y value and which one has the lowest y value. So let's start with my endpoints. G of 0, plugging into my original function. Sine of 0 is 0 minus cosine of 0, which is 1, which is negative 1. So that endpoint is at 0, negative 1. So now I can plug in my other endpoint. Let me just go ahead and do pi. So sine of pi is 0 minus cosine of pi, which is negative 1, which is 1. So that's pi 1 as another point, end point. Now let's check my local max to see if it's higher or lower than this highest value on my end point. So let's check g of 3 pi over 4. So 3 pi over 4 over here, sine is going to be positive, square root 2 over 2. Cosine is going to be minus a negative square root 2 over 2. So this is 2 square root 2 over 2, or square root 2. So that point is 3 pi over 4, comma, square root 2. Well, square root 2 is bigger than 1. So that means that this point here is my local, I'm sorry, not local, it's my absolute max in the interval 0 to pi. So 3 pi over 4 square root 2 is the absolute max in the interval 0 to pi. And then our lowest value is here. So this is my absolute min on the interval 0 to pi. And then this point is just in the middle. So since my function was continuous on that closed interval, I was able to use the extreme value theorem to test my endpoints and my local max to see what the absolute max and min are over that closed interval.